Hello, my name is Robert Rich, and I'm here again with Sriharsha Rao of TI's Haptics team as we continue our discussion of haptics. Sriharsha, when we left off, you were telling me about the difference between piezo actuator and inertial motor-based haptics. So what is the difference?
Inertial motor-based haptics are the most common and low-cost haptics actuation technology used in mobile phones today. There are two types. The eccentric rotating mass actuator, or ERM, is a rotational motor with an off-center mass. The linear resonant actuator, or LRA, consists of a spring mass system that vibrates in a linear motion. Piezo actuators are ceramic materials that bend when a voltage is applied. The piezo haptics actuator thicknesses vary between 0.5 millimeter and 3 millimeter. Piezo actuators can be mounted to the touchscreen or LCD to displace the touch surface, only resulting in localized haptics. Piezo actuators are either single or multi-layer. Single-layer haptic actuators need up to 100 volts peak-to-peak to 200 volts peak-to-peak to drive. Multi-layer haptic actuators need up to 30 volts peak-to-peak to 50 volts peak-to-peak to drive. The inertial motor-based actuation elements can be used to provide cost-effective haptics. However, they are characterized by a long response time, bulky size, and lack of high-definition haptics. Piezo-based haptics have a considerable advantage over the inertial motor-based haptics.
So what are some of TI's products to enable high-definition piezo haptics?
The DRV8662 is TI's flagship analog input piezo haptics driver and features an integrated 105-volt boost switch, power diode, and fully differential amplifier, resulting in a solution size that's 50% smaller than the leading competition. The DRV8662 also costs 40% less than competing solutions thanks to a highly integrated design that eliminates the need for a transformer. With the capability to drive a wide range of piezo actuator voltages as well as fast startup time and excellent thermal dissipation, the DRV8662 is an ideal solution for designers creating fast, flexible haptics designs. It drives haptics frequencies up to 500 Hz, enabling a wide variety of high-resolution haptics effects. It supports 4 GPIO control gains, 28 dB, 34 dB, 38 dB, and 40 dB. It has a wide supply range of 2.5 to 5.5 volts with direct battery connection, reducing solution size and cost without the need of an external transformer. Thermal overload protection prevents damage when the device is overdriven. A startup time of 1.5 milliseconds enables designs requiring fast haptics responses. The DRV8662 is an analog input piezo haptics driver and can be driven by a filtered PWM input. The PWM can be generated either by an apps processor or the MCU. The DRV8662 features a highly integrated transformerless design that cuts the overall solution size by more than 50% compared to the nearest competitive devices. Using a small, low-profile inductor instead of an expensive transformer also saves cost.
So let's summarize the DRV8662's key value proposition. It has a reduced solution size resulting from a 50% smaller area with the removal of the external transformer, as well as a solution cost that is 40% less without the expensive external transformer. Finally, robust system design schemes are enabled with 200 volts peak-to-peak to 50 volts peak-to-peak differential drive for high-definition inaudible haptics effects that can be driven by a multitude of processors with single and multi-layer haptics piezo actuators.
That's it. Exactly.
Great. We hope you enjoyed this discussion and learned a little bit more about haptics. For more information about the DRV8662, visit the URL below. If you have questions about implementing haptics in your own designs, visit TI's E2E forum. Thanks for watching.